So, hello students, welcome back. Good afternoon, you all. So, as you can see, yesterday we covered some basics of complex number which involved modulus and argument, the uh, algebra of complex number and such. Today, here are the topics that we are going to cover today. Now, for that, we need to see the theory first, and then, like yesterday's session, after that, we'll solve MCQs. So these are the topics. First, we'll do polar form, Euler's formula. This is an important one for advanced, JEE advanced, coordinate geometry with complex numbers, then cube roots of unit and D modules. These two are the most asked questions for mains, and it is also very simple compared to others. So let's start without further. First is polar form, which is also known as modulus amplitude form. Generally, we don't use this name, or we'll never use this name, because polar form is fine. Yeah. So let's look at the polar form. It is a complex number denoted by xy. We saw this yesterday. After this, we saw this is the modulus. So basically, polar form means in the form of magnitude, that is amplitude and modulus. So here, this is the modulus. We saw all this yesterday, and this is the amplitude. So what will be the polar form? Polar form will be here x equal to r cos theta, y equal to r sin theta in a right angle triangle. So let's see further. We saw this. Now x plus iy can be written as like this. And if we take r common, we get the polar form. I hope you can see it. R bracket cos theta plus I sin theta. This is the polar form of complex number. Some of you all are not muted. Okay, fine. Chalo. Next is notation. Basically, we will see many notations here. So this is the notation for cos theta plus I sin theta. That means it is known as CIS sin theta, cis theta. So basically, whenever we see this, this means cos theta plus I sin theta. Many of you all must not be aware of this notation, but it is generally used. In many textbooks, you will see. And after that, we know the standard result that cos theta minus I sin theta will be equals to cos of minus theta plus sin of minus it. We have listed some of them here. As you can see, x is the polar form, and x minus iy will be cos theta minus I sin theta, which is cis theta, CIS of minus theta. Got it? And obviously, conjugate means we just replace I with minus I. So these both will be same, z bar and cos of minus I theta. We also saw this yesterday by the diagram. If you remember, reflection along x-axis, if z is in first quadrant, reflection will take z bar in the fourth quadrant. So we got this result, or we proved this result yesterday, as you can see here. After this algorithm, this is basically theory in NCERT. You will find such questions that we will be given a complex number in x plus iy form, and will be asked to convert it into the polar form. Minded, it is very useful in JEE also. We will see how it is useful in JEE for solving problems. But let us see now how we can convert it. So we all know alpha will be tan inverse of y by x, which is the amplitude, and we can easily find it. Now, depending on which quadrant the complex number is, we can actually get alpha. Do you remember the range of argument of z? What was the range? It was from minus pi less than argument of z less than equals to pi. So this was the range of argument of z. If we discussed it anti-clockwise like this and clockwise like this. So according to the complex number quadrant, which quadrant is a complex number, we can actually find the amplitude of Z. I hope you all know this. First quadrant mein same theta equals to alpha. Second quadrant we have to do pi minus alpha. Can you guess third quadrant? It is alpha minus pi. And lastly, in the fourth quadrant, it is minus alpha. Because in the third and fourth quadrant, we measure in clockwise direction. Therefore, it becomes negative. Let's see the next. Theta we can see and we can know the modulus of Z. So this can be written as cos theta plus I sin theta. Chalo. Next is Euler's formula. I hope you know Euler's formula. He just gave another form of polar form, which is exponential form or Euler's form. He said that cos theta plus I sin theta can be written as e raised to I theta. We'll be using many times here, and with the help of Euler's formula, we'll also be able to prove further results. We'll see in the next slide. So here you can see Euler's formula. This is the now some deduction, some standard results which will help in solving the problems faster. So let's see. This is e raised to I theta. So if I replace I with minus I, I'll get cos theta minus I sin theta, which is e raised to minus I theta. So this is the standard result. Two results we have to remember: e raised to I theta and e raised to minus I theta. Got it? Now the next is 1 upon cos theta plus I sin theta. That is, we basically call it the conjugate. So what is the conjugate of 1 upon cos theta plus I sin theta? It is e raised to minus I theta, which is basically cos theta minus I sin theta. So we can directly write this instead of going through these steps. Obviously, these steps will make no time. Like in 1-2 seconds, you can go through these steps. But still, if it is easier, even 1-2 seconds are very important for the exam. That means 1 upon this in notation form it is written. Got it? Next, if we multiply two complex numbers, one with argument theta and one with argument phi, then basically their arguments will get added. As we saw this already yesterday in properties of argument, that argument basically follows log. So if two arguments are multiplied, then that means it will get added. Got it? And same is for division. So we are not repeating again. This is just for notes purposes. Now the main part next is distance, or you can say coordinate geometry. So in coordinate geometry, you remember we learned straight line, circle, conics. So here we will be only studying the distance formula, section formula, equation of line and equation of circle. We are not going to study conics. Got it? So here, if there are 2 points, Z1 and Z2, and we need to find the distance between the 2 points. What is the distance between the 2 points? Normal distance formula. But in Argand plane or in terms of complex numbers, the distance will be mod of Z1 minus Z2. Mod of Z1 minus Z2. Got it? Next is section formula. Section formula is same. We have two, internal section and external section. Same formula. If there is a point P which divides AB, what is the complex number related to a Z1? This is Z2. In the ratio M is to N. Then I personally prefer this diagram because I generally get confused about this. So M goes with B, N goes with A. So we get MZ2 plus NZ1 upon M plus N. And similarly, if the division is external, just we get minus sign here, as you all must know. Got it? Third is the midpoint formula. If we know section formula, midpoint kya hota hai? Sum upon 2. So that means we'll get Z1 plus Z2 upon 2. Centroid is also very simple. Centroid is used for a triangle, sum upon 3. So that's what, if 3 points form triangle, that is Z1, Z2, Z3, then the centroid will be given by Z1 plus Z2 plus Z3 upon 3. And lastly, we are going to study area of triangle. Area of triangle same in determinant form. You remember area of triangle in determinant form we studied in coordinate geometry. So here, what will be the area of triangle? Same, half into Z1, Z1 bar, Z2, Z2 bar, Z3, Z3 bar. Got it? Z1 conjugate, complex number conjugate, complex number conjugate. Since we have 3 points, this is the answer. Next is complex slope of a line. You remember equation of line? So in complex number, if a line is joining 2 points, then if we know those points that are Z1 and Z2, then what will be their slope? Slope will be Z1 minus Z2, Z1 bar minus Z2 bar. I hope it is clear. Denoted by W, general notation. In our coordinate geometry, slope is denoted by M. So this is the slope of line joining 2 points. Now, parallel perpendicular conditions. If two lines are parallel, slopes will be equal, and it is not the same for perpendicular. The sum will be 0. W1 plus W2 equals to 0. I hope you know why this. Now, this is the equation of a straight line. How does it read? A bar Z plus A Z bar plus B equals to 0, where B is a constant. A and Z are complex number. So, if this is the equation of line, what will be the slope? Minus coefficient of Z bar upon coefficient of Z. So, in this case, Z bar ka coefficient minus A upon A bar. This is my slope. Got it? Next is equation of circle. Center and radius. Circle may we have two forms, standard form and center radius form. In standard form, the center was at origin. So similarly here, if center is a Z0 and radius is R, then equation of circle is mod Z minus Z0 equals to R. And in general form, that is, if you remember ax square plus by square plus 2gx plus 2fy plus c equals to 0, that is this. Z bar plus A bar plus A bar Z plus B equals to 0. If you see, it is same, just we got this term Z bar. This is, I am just saying to so that you can remember it. And the center will be minus A and radius will be under root of A bar minus B. I hope you know what is A bar. A bar is mod of A square. So we can use if we need. Now geometry is over. Now let's talk about cube roots of unity. This is the second last topic before we start with the question. So cube roots of unity, basically, I only remember two properties, and those are, first let us see what are cube roots of unity, right? First, the value is minus 1 by 2 plus root 3i by 2, and second is minus 1 by 2 minus root 3i by 2. We denote this by omega and denote this by omega square. I remember only two properties, that is first and second. But rest all of the properties are easily derivable and we can easily derive it into questions. We'll see that later. And the second is this, forms a GP. You can see. Now, what is the last part? Last part is the de Moivre's theorem. De Moivre's theorem, you can say, is basically derived from Euler's theorem. You can easily see. I hope you know. This is a de Moivre's theorem, and these are the deductions of de Moivre's theorem, the same that we did with Euler's formula. So here, same, if it is cos theta minus I sin theta, then it will be cos theta minus I sin theta. N, basically, this N jumps into the angles. So it becomes N theta, N theta. Got it? This is the de Moivre's theorem. Yeah, and now these are the one second. Okay. I'll have to use the laptop. Yeah. You can see the note. Sin theta plus I cos theta. Many a time, we'll get this situation. So in this situation, we can do two things. One of them is either write sine theta as cos pi by 2 minus theta and cos theta as sine pi by 2 minus theta. That means the argument now becomes pi by 2 minus theta, or most of the times we'll use this. That is, take I common. If I take I common, I'll be getting this, and we do not need complex number in denominator, so multiply and divide by conjugate. So what did I get? Cos theta minus I sine theta. So this is the standard result that we'll see or we'll use many a times. Got it? So this is basically I of cos minus theta plus I of sine minus theta, and this is the result, cis minus theta. Now let's look at the questions. Chalo, we are finally done with the boring part for you, because we all know this theory part. We are just revising it. So let's now look at the more interesting part of problem solving part, which the main aim of this lecture is. I don't know why. Okay. Now, show that the 4 points in the Argand plane, these are the 4 points. Let us name these points. Yeah. So, let's this point be Z1, let it be Z2, Z3, and Z4. So, in the Argand's plane, these points will look like in the Argand's plane. Oh, this point, let this be A, it will look like 2, 1. Let this be B, it will look like 4, 3. Let this be C, it will look like 2, 5. And finally D, which is 0, 3. Got it? So these are the 4 points. Now, it is said to show that it is a square. So what are the properties of the square? Let me list it here. First is all sides are equal. All sides are equal means the figure will be either square or rhombus. What differentiates square and rhombus? If we are able to prove diagonals are equal. If diagonals are equal, then implies it is square, because diagonals are only equal in square and rectangle. We already eliminated rectangle here, so we need to eliminate rhombus, which is this. So these two things we need to prove. And how do we prove sides? If ABCD is a figure, then basically we just need to use the distance formula. I hope you all know the distance formula. So what is AB? Come on. I'm writing direct answer. Right? So 4 minus 2 the whole square, 4 plus 4. So I guess it is root 8. Same, let's calculate BC. 5 minus 3, 4, 4. So 4 plus 4 again 8. You know the formula, right? X2 minus x1 the whole square, y2 minus y1 the whole square. So similarly CD, 0 minus 2 the whole square, 4. 3 minus 5 the whole square, 4. And 4 plus 4, 8. And last side is AD, which is A into D. 2 ka square, 4, 4. So 4 plus 4, 8. So we proved this. This means that the figure is either square or rhombus. Now let's check the diagonals. What are the diagonals? AC and BD. So let's check length of AC. What is the length of AC? 2 minus 2, 0. 1 minus 5 minus 4 ka square, 16. That means under root of 16, which is 4. Let's see length of BD. What is BD? 4 minus 0, 4 ka square, 16. 0. So that is again under root of 16, which is 4. That means length of diagonals are also equal. and that means that the given figure is a square, hence proof. I already discussed yesterday that these questions are asked in JE, but how will they generate the option? They will just remove, show that, and square, and they will give me the 4 options: square, rectangle, rhombus, and parallelogram. So we have to check these conditions, and if these conditions are satisfied, it is square. So we are not going into that. Let's move to the next question, which is this question. If you remember yesterday's lecture, we skipped this question because it is a part of Euler's form. That's why we yesterday didn't do, but now we can easily do it. So how can we proceed? Im, that means imaginary part. We want the imaginary part of this. So let's say, suppose this is a complex number z. So z will be equals to log of minus I. Now minus I, can be written as cos pi by 2, or let us use the Euler form directly. Achha, this is the first question. So cos pi by 2 minus I sin pi by 2. Why? Because cos pi by 2 is 0, sin pi by 2 is 1. This will be minus I. And what is this? This is e raised to minus I pi by 2. This is minus I. We want ln minus I. So ln minus I will be equals to ln e raised to minus I pi by 2. So by property, we can take it minus I pi by 2 bar. This will be ln e, and ln e is 1. So minus I pi by 2. This is the value of ln minus I. So that means we got the value of this. This is equals to ln of minus I pi by 2. Now, by using property of log, multiplication to addition, we can write it as ln of minus I plus ln of pi by 2. And again, ln of minus I we got. What is ln of minus I? It is minus I pi by 2. So minus I pi by 2 plus ln pi by 2. Now we want imaginary part. So what is the imaginary part? This is real. This is the imaginary part. So that means imaginary part of z, which is required, is minus pi by 2. The number which is with I. So I के साथ कौन है? Minus pi by 2. So this is my answer. Correct? I think we also have options. Yeah, we again forgot to see the options. So my answer is option 3. I hope you can see it, minus pi by 2. Let's move on to the next question. Yeah, I think here also we have options. Chalo. We are given z in Euler form and we are asked modulus of this. So first let's calculate Iz. What is Iz? So if I get Iz will be IR e raised to I theta. Correct? Now what is, let's use expanded version. So IR cos theta plus I sin theta. We'll multiply I inside, so I'll get R I cos theta I minus I square. So minus sin theta. So basically we got R into minus sin theta plus I cos theta. This is the value of Iz. Now we require e raised to Iz. So e raised to Iz will be equals to e raised to R. So we'll multiply R also. So minus R sin theta minus plus IR cos theta. So I'll get e raised to minus R sin theta plus IR cos theta. Correct? Now by using exponential rule, we can write it as alag. We can write it as e raised to minus R sin theta into e raised to IR cos theta. We require its modulus. That means this modulus. Now this is a real number. So modulus of a real number, we write a real number itself. that is e raised to minus r sine theta into modulus of e raised to I r cos theta. Now, I hope you remember this result कि modulus of e raised to I theta. Once I modulus, modulus of e raised to I theta is 1. Why? Because e raised to I theta is cos theta plus I sin theta. So that means modulus of e raised to I theta will be under root of cos square plus sin square, which is equals to 1. Therefore, this is a standard result. Now, you can see here, we got the same thing. Instead of theta, we have r cos theta. Let me change the color, or we can't change the. Okay. So instead of, you can see here, I'll highlight it. Instead of theta, we got r cos theta. It makes no difference. So this value is basically 1. So my final answer is e raised to minus r sin theta. Is it in the option? E raised to minus r sin theta. Yeah, it is option A. I hope you got it. Correct. So let's see the next question. Yeah. Find the value of x, y, and z. So you can see here, A, B, C are angles of triangle. Do you remember the notation? Says this is basically e raised to IA cos theta plus I sin theta e raised to I theta. Just in place of theta, we have A. This is e raised to IB. This is e raised to IC. We are gonna find the value of x, y, z. Means we have to multiply this. So if I multiply this, here we are using the exponential form or the Euler form. So if we multiply this, we get a very easy e raised to IA into e raised to IB into e raised to IC. By using the property of exponential, I can write e raised to A plus B plus C. And A, B, C are angles of triangle. What does this mean? That sum of all angles of triangle is 180 degree. This is my answer. So e raised to I pi. What is pi? 180. This is basically cos pi plus I sin pi. Sin pi is 0, cos pi is minus 1. So my answer is minus 1. So x, y, z equals to minus. Let's see the next question. Yeah, this is again an interesting application of Euler's, or you can say de Moivre's. We can use any. I hope you know that Euler and de Moivre are exactly the same. There is some difference, the power difference. But so here x is given this. This is basically what? E raised to I theta, or you can say cis theta. So what will be x raised to the power 6? It will be e raised to the power I 6 theta. I skipped one step. Is it fine? It will be e raised to I theta raised to the power 6. Correct? So that means it will be e raised to I 6 theta, which is cos 6 theta plus I sin 6 theta. Now let's find 1 upon x. What will be 1 upon x? E raised to I theta. So 1 upon e raised to I theta. That means e raised to minus I theta. So what will be 1 upon x raised to the power 6? Same e raised to minus I 6 theta. I hope it is clear. Which means this is cos theta cos 6 theta minus I sin 6 theta. What we have to do now is we have to add x raised to the 6 and this both. So if we add these, see, this will get cancelled and we'll be left with cos 6 theta plus cos 6 theta. So my answer will be 2 times cos 6 theta. I guess we also have options here, which we again forgot. Yeah. No, we didn't have. So this is the answer, which is 2 cos 6 theta. I hope it is clear. Let's move on to the next question. Yeah, the next question is based on cube roots of unity. Again, these are show that question. They can easily be converted into MCQ types, so don't worry. Cube root of unity, we have two properties. That is, do you remember? 1 plus omega square is equals to 0. And second is omega cube equals to 1. So let's start with this LHS. And what is 1 plus omega from here? 1 plus omega will be equals to minus omega square. The whole cube. What will be 1 plus omega square from here? 1 plus omega square will be minus omega. So I'll get minus omega raised to the power 3. This will be minus omega raised to the power 6 minus omega cube. We can take minus omega cube common. I'll get omega square. Am I right? Instead of taking common, let's use this property. Omega cube is 1. It will be easier for you to understand. So I can write minus omega cube raised to 2 minus omega cube. Omega cube is 1. So minus 1 square minus 1, which is minus 2. This is my answer. Minus 2. Hence proved. So you can see cube roots of unity questions will be relatively simpler if you know these properties. Let's see the next question. Same, it is a cube root of unity question, but it is somewhat interesting than the previous one because here we need to do some manipulations. Again, we'll start with this side. You can see here we'll group 1 and omega square together. So I'll get 1 plus omega square minus omega raised to the power 5. But it plus 1 plus omega minus omega square raised to the power 5. Now, do you remember 1 plus omega square, or should I write it again? This is the last time I am writing. 1 plus omega square equals to 1 and equals to 0. Sorry, yeah. And omega cube equals to 1. So what will be 1 plus omega square? It will be minus omega raised to the power 5 plus minus omega square raised to the power 5. So you can say minus 2 omega raised to the power 5 plus minus 2 omega square raised to the power 5. So what we can do here? We can take minus 2 raised to the power 5 common, and we'll be left with omega raised to 5 plus omega square raised to the power 5. I hope I didn't make a mistake. Yeah. Let's see if we get 32. I didn't make a mistake. So what is minus 2 raised to the power 5? It is minus 32. Omega raised to 5 can be written as omega cube into omega square. And omega cube is 1. This is basically omega square. And omega square raised to the power 5 is omega raised to 10. Now minus 32, I can write it as omega square plus omega raised to 9 into omega. This is same. You will notice many questions where higher power is same as IO does. I square, I cube, I raised to 40, I raised to 59, I raised to 81. So just there we used square. Here we have to look for multiples of 3. So omega 9. Omega cube is 1. So omega raised to 9 will be 1. So minus 32 omega plus omega square. What is omega plus omega square? It is minus 1. Minus 32 into minus 1 is 32, which is RHS. Yeah. So we didn't made a mistake here, or I didn't made a mistake here. So let's see next questions. Find the cube roots of 8. Yeah. So these questions are the very basic questions asked, but we'll see this more complicated version further, but it is important to know the concept. These are directly asked questions in JEE mains. So cube root of 8. So let me tell you, cube root of 8. We all know that in an algebraic equation, the power denotes the number of roots. That means if I write an equation, x cube equals to 1. What is the power? 3. That means this will have 3 roots. So here cube root we have to find. When will we able to find cube root? When we have cube. So when we have cube, that means we got to have 3 roots. So cube root of 8, one answer we directly know, that is 2. 2 is the cube root of 8. So we know that one answer 2. We need 2 more. So for that 2 more, what we do is, see this manipulation, it is very helpful. We'll write it 8 into 1. Obviously I can write. Then I can write it as cube root of 8 into cube root of 1. Right? What is the cube root of 8? It is 2 into. What are the cube roots of 1? Cube roots of 1 are, we know that, right? 1 omega square. Now we need to multiply it with 2. So cube root of 8 will be 2 omega and 2 omega square. We already got 2 here, but the others, which are 2 omega and 2 omega square, we did not get directly. Such questions can be solved by simply multiplying with 1 and then cube root of 1, we know 1 omega square. So these are my answer. Let's move on to the next question. Simplify. Yeah, now this is a classic question which is based on, you can either use Euler or De Moivre's. I generally prefer Euler because it is easy to use the exponential rules. So this is basically e raised to the power I alpha. And in denominator, do you remember we had 2 conditions if this came? The first was to write pi by 2 minus beta, pi by 2 minus beta. And the second was to take I common. So if you don't remember the direct result, we can derive it here, take I common. So this will be equal to I 1 by I sine beta plus cos beta. 1 by I will multiply and divide by I. So I'll write cos beta first. Here I'll get I square, that will be minus 1 minus sine I beta. This is basically I into e raised to minus I beta. So what we have here is e raised to I alpha raised to the power 4 upon. This is I e raised to I minus I beta raised to the power 8. I hope it is clear. Now just use exponential rules. What we'll do, we'll multiply 4. So I get e raised to I 4 alpha, I raised to the power 8 into e raised to minus I 4 beta. Now we can use exponential rule here. It will get added. So I'll get 4 alpha plus 4 beta upon, what is I raised to the power 8? I can write it as I square raised to the power 4. Right? Now we can also take 4 common. Did we made, array, this is 8, yeah, right. This is 8. So 4 plus 8. So I square is minus 1. Minus 1 ki power 4 is 1. So denominator is gone. Numerator I can take 4 common. I'll get alpha plus 2 beta. If you want, we can write it as in the expanded form, which is cos 4 alpha plus right, 4 alpha plus 8 beta plus I sine 4 alpha plus 8 beta. The answer देख के feeling नहीं आ रही है कि right है. Did we made a mistake somewhere? I don't think. ऊपर तो add e raised to I into 4 alpha. Yeah, I think we did not made a mistake. It's fine. Got it? Chalo, let's move on to the next question. Yeah. Now, these are the questions where I said he will be very helpful of that part. What? converting a complex number of x plus iy form into a polar form. How? Because basically, let me tell you, the polar form or exponential form is used whenever you have some higher power. So if we notice last two questions, we had the power 4 and then 8, and before that also we had higher powers. Here also we have raised to the power n. So basically, if in a question we see higher powers, then it is a hint that we have to use exponential form. And to use exponential form, we need to convert this into polar form. So that is the main part of converting exponential form into polar form. Now, how did we do here? Yeah, 1 second. Okay. So here, we'll do step by step. Let us consider this. So 1 plus I raised to the power n. I can multiply and divide by 2 raised to the power n. So I'll get 2 raised to the power n, 1 by 2 plus 1 by 2 plus 1 by 2 I. Now, see what I can write 1 by 2 as cos 60 degrees plus I sine, I think we should multiply by root 2. Yeah, because then it will give us same angle. So pi by 4 plus I sine pi by 4 raised to the power n. So root 2, this is root 2 raised to the power n. What is this? This is e raised to I pi by 4 raised to the power n. So I can write root 2 as 2 raised to the power n by 2 because root is upon 2. And I can write it as e raised to the power I n pi by 4. Now I'll expand it again. So I'll get 2 raised to the power n by 2 into cos n pi by 4 plus I sine n pi by 4. So now just consider this. We will not solve because we are smart. Here there is only minus sign. So that means here we'll get minus sign. Here we'll get minus sign. I hope you understand. Correct? So here we'll get minus sign, and if it is minus here, we'll get minus here. So basically, they are saying कि एक plus वाले के साथ add करो, एक minus वाले के साथ. So can you tell me directly what are they asking? You have to add these two. So these two, let me write it here, will be equals to C. First is positive one, so 2 raised to n by 2. I'll take common. Positive one में था cos n pi by 4 plus I sin n pi by 4. And then add negative one. Negative one में क्या था? Cos n pi by 4 minus I sin n pi by 4. Simple. Now, can you see what is getting cancelled? This is getting cancelled. So basically, I'll then get 2 raised to the power n by 2 cos n pi by 4 plus cos n pi by 4, which is 2 cos n pi by 4. And if you know, we can group this by using exponential as 2 raised to the power n by 2 plus 1 into cos n pi by 4. This is my answer. Right? Same. Again, if it must be asked in MCQ, they'll not give this. They'll give this in options with other options. So I hope it is clear. So this is the biggest hint. Whenever we have higher powers, it is a hint to use Euler's or De Morgan. And for that, we need to know how to convert it into polar form. This was one of the way of converting. There are other ways. I hope you have learned it, but this is the fastest way. Let's see the next question. It's again on cube root of unity. Yeah. So this is the same question, I guess, right? The 32 wala, if you remember, I don't think we need to do it, right? Same, na? I can group these two. 1 plus omega square minus omega raised to 6. And here we have this only 1 plus omega minus omega square raised to 6. अरे ये 32 वाला क्या था ना, इधर 32 था, जब पावर 5 थी. ठीक है, we'll see next. This is interesting. Now we have to prove this. Obviously we start with this side, LHS. चलो, LHS में there are 3 brackets in multiplication. I decided let us multiply these two. So if we multiply these two, you can multiply any. You can multiply these two, any. But this second one ना, अभी आदत second third को multiply करने. So I'll get a omega. So a square omega cube plus ab omega square plus ab omega raised to the power 4 plus b square omega cube. So omega cube is 1, gone, 1, gone. So I got a plus b. Let's write it together. I get a square plus b square. यहाँ से we can take ab common. I'll get omega square plus, what is omega raised to power 4? Omega raised to power 4 is omega cube into omega. Omega cube is 1. This is basically omega. I know I am skipping one step or two steps in between, but it is necessary because I want you to also make a practice of skipping steps without making a mistake. It increases speed, and speed is a crucial part of cracking any entrance exam. That's why I'm making it a habit to skip 1-2 steps every time. Got it? So you also make the same habit. I'm not writing it again. We know omega plus omega square is minus 1. So basically we got a plus b into, let me rearrange this. This will be minus ab, a square minus ab plus b square. Do you remember this factorization formula? This is a cube plus b cube, right? A cube plus b cube is a plus b, a square minus ab plus b square, which is RHS, hence true. Got it? Let's see next question. This is the same. You can see again, we have 3 brackets. Again, we have to open the second and third one. The procedure is the same. What are we gonna do? Open the second and third, group the terms, and then I'll get this, right? So let's say I will be skipping steps. So this will be x plus y plus z into x into x. We'll get very kachra, we get 9 terms. X square plus x y omega square plus x z omega. These are the 3 terms. Should I write one below the other? It will be beneficial, na? Plus x y omega. So x y omega plus y square omega cube plus y square omega cube and y z plus y z omega square. Now let's multiply third. X z omega square, then y z omega raised to the power 4. y z term नहीं है ना? इधर क्यों लिखा है? We got x z omega square. So x z है क्या? हाँ, here it is. x z omega square plus y z omega raised to the power 4, and lastly we'll have z square omega cube. Now these terms, x square, y square, z square, we'll group it together because omega cube is 1. So I got, this is the same, x plus y plus z. I got x square plus y square plus z square. See this? We'll group this together. We'll take xy common, and I got omega plus omega square. Similarly, here we can take xz common, and we'll get omega plus omega square. And lastly here, we'll take yz common and we'll get omega square. What is omega raised to the power 4? Omega. Last time we did. Last question. Yeah. And what is this? This is 1. Sorry, minus 1. This is minus 1. This is minus 1. So my finally I got x plus y plus z into x square plus y square plus z square minus xy. I'm writing this first. Minus yz and lastly minus zx. Now, if you know factorization 10th standard, then you know this is a factorizable form of this. So basically, this is equals to x cube plus y cube plus z cube minus 3xyz. Simple, not simple. Calculator. Got it? Let's see the next question. Prove that. Yeah. So again, it is a prove that question. That means this is 0. Answer to 0 आना चाहिए. We know the value of 1 plus omega square. 1 plus omega, it is minus omega square. We'll keep it aside. We'll group these two. So 1 upon 1 plus 2 omega plus 1 upon 2 plus omega. And this is minus 1 upon minus omega square. We'll take LCM here. We have to simplify. That means there is only one option. We can take LCM. 2 plus omega plus 1 plus 2 omega upon 1 plus 2 omega into 2 plus omega plus 1 upon omega square. Here we'll multiply and divide by omega. So denominator will get omega cube. What do we get here? 1 plus 1, 3 omega, 3 omega. So if I take 3 common, I'll get 1 plus omega. Denominator में 2 plus, I am again skipping steps, huh? Omega plus 4 omega, 5 omega. किधर मिस्टेक नहीं किया ना? Plus 2 omega square. And this will be plus omega because नीचे तो omega क्यूब आएगा. ऊपर 3 into 1 plus omega upon. Niche you can see, we can take 2 common. If we take 2 common, we'll get 1 plus omega square. What is 1 plus omega square? Minus omega. So this is basically minus 2 omega plus 5 omega. Correct? And we have plus omega. So we got 3 into 1 plus omega upon 3 omega plus omega. So 3 gets cancelled. If I split, I get 1 plus omega plus 1 plus omega. What is 1 plus omega? 1 plus omega is minus omega square. Sorry, 1 plus omega is omega square. We'll multiply and divide by omega square, na? Plus 1 plus omega. And this is 1 plus omega square, which is 0. Hence proved. Should we do one last sum or bus? Let's do a last question. Inequalities. Inequalities are asked rarely, but this is a question I bought. It is a previous year. It is asked in JEE. Very simple question. Very simple. Like 10 seconds में question हो जाएगा. If you know the formula, mod of Z1 plus Z2 is less than equals to mod Z1 plus mod Z2. And if you know a common concept, as I will discuss afterward, let's see this. The basic idea in solving such questions, maximum and minimum value questions, is to use the inequalities. If we use the inequalities, it becomes relatively simple. Now, which inequality to use? For maximum, we'll use less than equals to. Why? Because if x is less than equals to 3, that means max value of x will be equal to 3 because the rest of the value will be less than 3. Got it? Therefore, for maximum questions or questions based on maximum value, we use a less than equals to inequality. So the idea is we have to form this. in this. So I can write it as z plus 3 minus 5 and the sum is over. See this? I formed z plus 3 here. Now this is z1, this is z2. What is z1 plus z2? z1 plus z2 is less than or equals to mod z1 plus mod z2. What is mod z plus 3 given? 2. Mod 5 is 5, that is 7. So that means less than equals to 7 means maximum value is 7. I guess we have options also. Yeah. So you can see we have option number 3 as my answer. I hope today's lecture was good and you got to know some questions. Now we have completed complex number and we'll meet you in the next Saturday Sunday session where we'll solve more questions not on complex number, other chapter. Got it? Let's end the session here. Thank you all. Thank you very much. Bye bye.